In this segment, we're going to be taking a look at VRRP, or the Virtual Router Redundancy Protocol. It's a pretty slick deal that allows us to have a gateway spread across multiple virtual routers so that if we have a catastrophic failure of some sort, our clients have a little bit better chance of leaving their subnets. VRRP solves this problem that we can't have multiple gateways configured on a single host. And typically in a subnet, we're not going to have more than one layer 3 device handling traffic for different routes. We're going to try to run everything through one router, or at least one virtual router spread across multiple physical systems. The problem with having just one single gateway is it introduces a single point of failure. So if that router had to go down for maintenance, had a hardware failure, someone cut the cable, whatever it might be, if something happens to your one and only gateway, all of the traffics that are sitting behind that can't get out to the internet or different subnets within your network. So that's obviously a pretty bad deal, and you're definitely going to hear about it as an administrator. So what we want to do is we want to take advantage of some of the layer 3 devices that we have and hopefully create multiple points of failure to protect ourselves a little bit from those types of situations. So what VRRP does is allows us to use layer 3 switches, routers, or firewalls, really any device capable of layer 3 communications and knowledge of the VRRP protocol to split this gateway, or the single point of failure, across a few devices like we had talked about. What kind of happens here is we're stuck in that same problem of when you go to configure an IP address, even though we have multiple settings for things like DNS, we could set up backup IP addresses, things like that, there's not really much you can do with your default gateway here. Even if you could configure two default gateways, how would your host know which one to use? Right? If we pointed at two different routers, they might have totally different ideas of how to get to a destination network, and it would be a little bit chaotic. You can kind of simulate this too. We can't have the same IP address existing on multiple gateways because we have problems of which device really owns that IP address. We get the duplicate IP conflict type of scenario. If you've ever wanted to kind of break your own network, set your laptop's IP address to have the same IP as your default gateway. Your laptop for sure won't work, and any other hosts that are trying to get out will have about a 50-50% acceptance rate of their packets actually reaching the real gateway. So what we do instead is we create a virtual IP address, point all of our endpoints or our clients to use that virtual IP as their gateway, and have that virtual IP address present on multiple layer 3 devices. What this allows us to do is still manage the actual layer 3 devices using their real physical IP addresses, or their IP addresses tied to a physical interface rather, and then have our clients use the virtual IP address to get out and use that as the gateway. What happens is one of these layer 3 devices will be elected as the master router or the master device where all of the clients should send their traffic outbound towards. If something were to happen to that master device, we have a series of backup routers or backup layer 3 devices that can take over the ownership of that virtual IP address and handle all of the traffic that's being thrown at the gateway. This is an election process that happens based off of priority. The priority values that you set up on the routers range from 0 to 255, with the higher number being the more likely one to have the master status. So a router with a priority of 255 would almost always be your master router. Anything lower would be designated as backup routers. We'll talk about that a little bit more. Now this is a topology example from Juniper, and they've given us the scenario with two layer 3 switches and a bunch of hosts connected to that internal subnet. The internal subnet being the 10.1.1.0 subnet. What they've done is they've taken those two layer 3 devices, those two layer 3 switches, and given them a virtual IP address of 10.1.1.1. All of the clients will point their default gateway to that IP. Switch A has a real IP address of 10.1.1.251, and switch B has a real IP address of 10.1.1.252. Now when you look at these switches, you can see that switch A has a higher priority, meaning it'll be the one that the clients use when they need to get out. So if a client was going to go to Google or something other than the subnet that they're on, their packet's going to go towards the default gateway of 10.1.1.1. VRRP designates that switch A because it has a higher priority, should be the master router, so the packets will actually traverse through switch A with that. It's kind of a neat setup. If switch A goes down, switch B has the second highest priority. No big deal, it can take over and route all of those packets out to the internet or whatever subnets that these hosts are trying to get to. When switch A comes back up online, so after you fix the problem, replace the cable, whatever it might have been, switch A has a higher priority than switch B, so switch A actually takes over the master status back from switch B. It's kind of this self-healing type of scenario that we have, but it's really cool how we get redundancy out of that. Now there's a few things that you need to know, just small details here kind of behind the scenes. VRRP is dependent on multicast, at least in the IPv4 world of 224.0.0.18. And these multicast packets handle not only the hellos, so trying to figure out if the other neighbors are there or if they're alive, but it also handles the election process carrying the priority values for all the routers participating in VRRP. Now I said here, I think this is actually a little bit off. The priority values should really actually be from 0 to 255. It might be a vendor-specific thing. I know if you actually go into the Juniper SRXs, it is 0 through 255, but you get the idea. We have a range of values that we can set up for the priority. If there's a tie, so if I set all of my routers to be a priority of 200, VRRP chooses the router with the highest IP address. Now there's two more properties of VRRP that we'll talk about. These two properties are preemption and advertisements. Basically what preemption allows us to do is when a router enters the VRRP scenario and it has a higher priority than any of the other backup routers or even the master router, the router with the highest priority will just take over that master status. So what it's saying is we don't really care when that event happens. If at any given point in time a router with a higher priority value enters our network, we're going to start shipping our traffic off to that router. Might be something good you want configured. It also comes with a few consequences as well. It's just an option that you should be aware about. The last thing that we had is the advertisements and the intervals for that. We send out packets or these advertisements every 1 second by default. So kind of checking in with our neighbors, checking that election process. You can delay that a little bit, but know that when you change the advertisement time, it might take you longer to fail over to a different router. That would be your backup becoming a master there. So as you can see, VRRP hopefully is a pretty cool protocol. There's not a ton of stuff that you need to configure with it, but it's useful in a lot of different scenarios. We actually use it here on campus with all of our buildings. So all of our buildings have a couple layer 3 switches within them, and we have this kind of mesh topology throughout campus. It's nice because if we have to take a switch down for maintenance, or if there is sometimes a problem with one of those switches, our clients in all the buildings are generally pretty unaware if anything was happening because VRRP seamlessly fails them over to the working backup device. So that's all for this one, just a quick overview of what VRRP is, some of the things that you need to be aware about, and of course how we're going to use it in our upcoming labs.